Says, watch Judge 30.
Some people will be asking themselves after to see the pictures of the new cars, why so different approach between, we can say, Ferrari and McLaren, and we can say Red Bull and Lotus, Force India plus Sauber. In the front suspension, wishbone thing. If we took the same reference on the ground, and we say, for example, we go to the section on the chassis, on the front, where the front suspension is fixed. Driver will be there, and after this is going. But we concentrate only in this part. And if this is the position of the central wing, that this is by regulation shall be the same for everybody, because they are supplying the profile coordinates, and after the wing, after that, the wing can go in different shapes and deflectors and top deflectors and flaps and end plates and all that, and related to the front wing. But we forget that. We think now these are the two vertical supports, and after the lateral wings will be going there, like this or like this. Each one is going for this different approach in wind tunnels and especially CFD. The question is why some people are using the very high nose on the very hard part of the front wing, and with a high nose. If the nose is there as a maximum position given by the regulation, then why, for example, Ferrari is going practically with the wishbones in this direction? Very high angle. And they use here not push rod, they are using pull rod. But this is something that I don't like to come in, because somebody, for example, can go for the push rod or can go for the pull rod. Then that is something that is better not come in, because for other reasons. The question is, roll center will be going at some distance. Why? Because they want to go very, very high to permit having this area, very big area, then it's very low blockage for the flow crossing that area. That is between the two plates that support the front wing. Other cars are different. This area is much lower. They don't go exactly at the maximum that is permitted by the regulation. They go practically there, and they go now, because this is much lower than here, is one delta in this H here, and here will be a delta. H plus delta, here is only a H. Then why these people are using the position of the wishbones much lower than that? Then the roll center will be practically much lower. This distance, if we compare, one is here, the other is there. That is much more concentrated in maximum clean area passing below the nose, and we can say if this is the top that given by regulation for visibility for the driver, and if the chassis is finished here and it's going like this, then they try to go this 50 millimeters down, that is by regulation need to be there, but at the same time they go like this, very high. This car will go the same with this position here, but they will have the chassis much lower, and then the chassis will go something like this. This is B and this is A. Then what I say is they are looking for this amount of air circulating in Ferrari and McLaren in this part of the car. Here is the front wing. Then this is coming there. The other cars are the Red Bull, Lotus, Force India and Sauber are much lower, because they are working much more in a combination between aerodynamic reason and efficiency on what they define, what is the efficiency for rear tires, for front tires, in the condition that need to work during the race when it's under heavy braking or under high speed, when the circuit is not flat and you have a very high downforce, and then will be a big vertical displacement here by the force, vertical force coming by aerodynamics, or by transferring load to the front axis through in braking. A heavy braking like Monza, that you have more than 5.5 G in braking, then you transfer a lot of mass to the front, and then the front will be moving down. The question to me is, okay, when this will be moving down, it's true that this distance will be very low, but maybe it's around 12 millimeters or something like this. If going down, this point will be moving parallel here, will be moving sideways, and will be forcing the structure sideways. Then we put here a shear load on the compound much higher than in one lap. This will be, because puts big stress and compression on the tire, then this will help to generate temperature on the tire, because we'll be working a lot of the sidewall. But for a long race, and especially when you have a lot of fuel, this not looks the better way. Then the only way that the other people are losing something for aerodynamic reason, but gaining something for less this shear load, because the angle will be moving, when this is moving down, this will be moving much less this distance here related with this distance here and there. Then what happened, the lateral wall will be working with lower shear load, and that shear load will be in the little skin that is on the tire, again the ground. Then you know that per lap you will be consuming one X thickness on the tire compound. This shear load here applied on the compound will be consuming per lap one X amount of in braking, cornering, and in the rear tires will be acceleration. But we are talking now front suspension, because rear suspension are very close between the cars. This will be directly related, this consumption, in the efficiency of the tire. Then if we say, for example, the tire starts with this efficiency, and after we have 10 laps, for example, the efficiency can go like this and go like this. But if you force too much here, the consumption will be going like this. Then maybe you go well 2 laps, but after you start consuming more, and then therefore you start losing lap time. The thing is, are 2 different approaches. One is pure aerodynamics approach, this system, and the other is an aerodynamic more conservative in aerodynamics, an approach more conservative in aerodynamics, but is much more thought in life on the compound effect for lap time.